So today we'll be modeling electrocoating of a car door in Comsol. So we start by going to the model wizard and we're using a 3D dimension. So we select 3D and it brings us to our physics. Let's use the primary and the secondary current distribution. So under primary and secondary current distribution, we'll select the primary current distribution, click on add, then we move to the study. This will be a time dependent study. So we select the time dependent and click on done. So the first thing we'll be doing after selecting our geometry physics is to import our geometry. So go to geometry and we'll have to import it from file. So at this top side, you see this import section. You click on it and it will take you to this place where you can choose to import or browse. So we'll select browse. So under the browse, we select this card or file. Okay. And we import it. This is what we have here. Field selected. Let's go to geometry and we'll add a block. Locate under the size and shape. For the height of this block will be 0.7. Locate the position in the X field, and that will be minus 0.1. In the Y field will be minus 0.03. Select field selected. So we want to add a cylinder. Add a cylinder. Let's add a cylinder. Under the size and shape of the cylinder, okay, the radius of the cylinder and the direction is 0.05. And the position in the X field minus 0.1. The Y field will be minus 0.03. And in the Z field, the minus will be 0.7. So, axis type, we want to change this to Y axis and field is selected. So under the geometry, we look for transforms. And we have the array. Let's go back to this cylinder one only. And under the x, the size, the, the size, let's change this to 3. Let's locate the displacement in the x field and we change this to 0.5. So for now, we're just building the geometry, then later we'll go to add our parameters and work on our physics, and later on we're gonna compute this. So this first section, I'm just showing how to build the geometry, add the parameters. Then the next section, I'll do a different video to show you how to um, work on the physics and measuring and studying this work. So we'll just select field selected and it adds similar cylinder to this steel section. So you should have something like this. Let's go to booleans and partitions and choose a union. Select array, this array, this array, this array, and this block of field selected. You want to delete some entities. We're looking for 'Need to find where we can delete some entities. So we have delete entities here. And choose the domain 1, 3 to 7. 1, 4, 3. Yes. Only 1, 3. We have 1, 3, 4. Only 1, 5. Only 1, 6. Only 1, 3, 4, 5, 6. So delete. We have build selected. Let's go back to the geometry. Sorry, we have transforms and we'll select rotate. We select all. So here you just press Ctrl all to select everything here. Under the rotation section, angle should be 19. Axis, we want to axis type over here, x-axis. And go to form union. And the fair tolerance for this, we'll use relative and we'll go for and you can see what we have here. So your geometry should look like this. If it's not looking like this, then please go back and follow the steps that I instructed to get something like this. Okay, now that we're done with building the geometry, we can move on to add our parameters. Parameters, same as we did for the geometry, just load, add a card of parameters. Should be here. That's done. Now we go to our definitions. We'll be adding some explicits. So under the geometric entities, choose the boundary, select boundary 2, 33, 34, 84, any. And let's rename this to anodes. and the explicit. So this did 233, 84, 84. Now, here will be so here we'll use a boundary. On 7 to 26, 29, 32, 36, 39, 41 to 77, and 29 to 83. This will be named the cathode. And the anode and the cathodes. As you can see, of the anode, you select the anode, you can see, and when you select the cathodes, you can see. Let me do some parts of the physics here. Let's go to the physics. We have the primary current distribution. Let's go to electrolytes. We want to find this to sigma. Let's add electrode surface. Select anodes. And this for the external electric potential. Make a E capital potential of the cell. Expand the electrode reaction. You should be able to find the equilibrium potential and change this value to equilibrium delta. So we want to set up the cathode, which is the car door, the model. Go to physics and we want to boundaries and we want to use a thin electrode layer. sorry, thin electrode surface. And let's look at cathode. We go to the dissolving depositing species, and we're going to add this as a table. So the species, we name this as rho, and this will be NEFF. Film resistance will be thickness and conductivity. And the reference film thickness here will be 0.1, and film conductivity will be 1 capital R underscore film. And the film thickness, this will be total film thickness, change up. And then here will be total film thickness change down. Boundary condition formulation, the current density, and we go to the electrode reaction. So under the electrode reaction, we go to the stoichiometric coefficients. We make here 1, and we are done for the physics. Let's go to the meshing. Let's make this user controlled. Under the size, make it pretty fine. Okay, pretty fine here. Let's make it fine. Let's add another size here. Here will be a boundary. And 7. Let's paste 7 here. And the element size, oops, be fine now. Now build or after meshing, we can this should be what you should be seeing after. So please make sure you have something like this for following my steps. If you have any questions, please let me know and I'll just address that. So when you follow what I've done carefully, you should have something like this. Your finished machine should look like this. I think we can go on to steady. I was thinking of doing this in the next video. Okay, I think I'll do that in the next video. So please, if you have any questions, please let me know and we'll do continue the rest of this video later. So thank you very much for joining to this point. And please don't forget to subscribe and always send me an email or if you have any questions or need any assistance. Thank you, and I'll see you.